Hello, this is my ELL project. My project is based on the functioning of an induction cooktop. The left image shows the image of an induction cooktop and the right image shows its component. The mainly discussed and thoroughly discussed component is the inductor coil in this project, through which an AC current passes and it creates a strong magnetic field around it. Now, discussing about the functioning of this device, and high frequency alternating current is passed to inductor coil which sets up a strong magnetic field. Now, if a workpiece, that is a cooking vessel, which must have ferromagnetic material, is brought closer to the inductor coil, then due to change of flux, eddy currents are produced, resulting in joule heating and thus cooking the food. Getting into detail that how this functions, we can understand the functioning of the induction heating by considering a case analogous to this, which is the operation of magnetically coupled transformer, where the primary winding is the inductor coil and the secondary winding is the workpiece or the cooking vessel that we use. In the primary part, that is the inductor coil, high frequency alternating current is fed and thus generating eddy currents in the secondary part, which is our cooking vessel. Discussing about eddy currents, which is generated in the workpiece, since the magnetic field in the vicinity of the workpiece and also through it keeps changing, this suggests that there must be an opposing phenomena to this change of flux according to Lenz's law. So here comes eddy currents in the picture. Eddy currents are currents that circulate in conductors that are caused by various magnetic fields, reason being the change of flux. Now, eddy currents convert the electrical energy into heat energy. We can use that heat energy to cook food. This is the idea behind induction cooktop. The induction cooktop devices use eddy currents to cook food without being hot itself. Now, there is a question that can a DC source be used in induction heating? Well, production of eddy currents is due to rapid change in magnetic field through the material, and this does not happen if constant DC current is supplied. An AC supply and with considerable high frequency of the range 25 kHz to 50 kHz is required to create change in of magnetic field through the cooking vessel, resulting in eddy currents. Now, considering the more components and circuits involved in induction heating, impedance matching. As in the case with any other electrical equipment, induction heating power supplies have maximum voltage and current limits that should not be exceeded. To send the greatest amount of power from the power source to the load, the power supply and load impedance must be as near as feasible. This allows the power voltage and current levels to reach their maximum permissible values simultaneously. Induction heating units do this via the use of impedance matching circuits. There is a component used which is the resonance tank circuit. In the system of resonance circuit, the energy supplied by the power supply oscillates between the capacitor in the form of electrostatic energy and an inductor in the form of magnetostatic energy. The energy keeps on getting reduced due to losses in the capacitor, inductor, and the cooking vessel in the form of joule heating, which is also called damping. It is this loss in the workpiece which is the ultimate desire for us to achieve the induction heating. This lost energy is actually utilized in cooking the food. This is the circuit diagram. Here, the first box is of power supply. Rectifier converts the alternating current to DC and inverter currents that DC current to a high frequency range alternating current, the impedance matching box, and the resonance tank circuit. There are limitations of induction cooktops. Not all conductors can be used as cooking vessel. The metal used in cooking vessel must have a strong response to magnetic fields because eddy currents are to be produced due to change in magnetic fields. The metal must have relatively high resistivity, because if it has a low resistivity, then there can be very large amount of eddy currents that the metal that in that case metal can melt, thus damaging the cooking vessel and also poisoning the food being cooked. Iron or steel are the most commonly used metal. They are ideal to use. Here are some important features of induction heating devices. Only the workpiece gets heated and not the source, because eddy currents are produced only in the workpiece. Whereas traditionally we used external flame or the heater to heat the workpiece, thus reducing thus we have reduced the heat loss significantly while using the induction cooktop. Since the workpiece can heat without being in physical contact with the inductor coil, so this avoids any type of contamination.